सर यूट्यूब रे सुबन
करछि करछि गोटे मिनिट कटि जाइछि हेलो एबे यूट्यूब रे सुबिला कि पचारला देखिला एबे लागुछि सुबिबो चारटारे भी लॉगिन कर दे जे एडमिट करिया को होई जीवो देखलु यूट्यूब रे सुबिला केबे से डिफॉल्ट हेगला से कटि जाइतला कहबी तो hello and now it will be you should be able to listen in the YouTube also. Now this structure from the discussions that we had by comparing it the microstrip antenna to the dual of a rectangular waveguide section, we can say that the microstrip antenna or the structure, this approximates a resonant cavity with short circuit walls on the top and bottom, which are the conducting patch and the ground plane, and open circuits on the other sides, on all other four sides. Now in this cavity, since it is a resonant cavity, therefore there will be resonance. So resonance will occur at discrete frequency, as in case of waveguide you are having different modes. For different modes there are different frequencies. So there will be resonance at discrete frequencies for certain modes which are allowed to exist. Admit kora now when we excite this antenna, तते कौन कहली आरटार कर दे आरटार एडमिट कर करी when we excite this antenna at a given resonant frequency, then there will be a strong field inside the cavity. That is first part. Second part, there will be a current on the bottom of the surface and the top of the surface, the patch, and this will produce significant radiation that leads to a good antenna. So this is the principle of microstrip antenna under which it operates. Of course, the radiation mechanism we will see in a later lecture. In a later lecture. Now let us see the analysis, simple analysis of a microstrip antenna. For that, let us see the voltage and current distribution for the microstrip antenna. Now if you have compared the previous slide with this slide, what I am showing here is the blue portion is the substrate, the yellow portion here is the top conducting patch. Now within the domain of the top conducting patch, it will satisfy the Maxwell's equation from which we will get the wave equation. So this is the wave equation that is written: dou square Eg plus dou square Eg with respect to x, dou square Eg with respect to y, plus kmn square Ez is equal to 0. What is k square mn? And that is the wave number. K is the wave number and corresponding to mth mode. M is the mode number, n is the mode number. Now this antenna is extended along x. It has its length. So 0 to L is its length. 0 is at the origin and L is the length along x. So extension along x is L. Extension along y is W, which corresponds to the width of the antenna. Now on the four walls, which means on the x-axis from 0 to L we have open circuit. Similarly, along the x-axis at from 0 to L on both the sides at 0, y is equal to 0 and y is equal to W, we have open circuits. Similarly, at x is equal to 0 and x is equal to L, along the y-axis we have open circuits, which means we have magnetic boundary wall on these four sides. Now, if we have open circuits on these along y and along x, then in those directions or on the open circuit, the derivative of the electric field is 0. So you can see on the four walls we are seeing the four derivatives to be 0. Dou Ez by dou y, which means there is no variation along y. Dou Ez by dou y is equal to 0 when y is equal to 0 and y is equal to W. Similarly, dou Ez of dou x is equal to 0 when x is equal to 0 or x is equal to L. Now, using this and the 2D wave equation which is within the domain of the patch and by boundary conditions now we have found, and the 2D wave equations that we have written, fields within the patch will have a solution which is similar to the solution of a waveguide. Now you know, for the waveguide this 2D wave equation has eigenfunctions given as, the eigenfunctions for the waveguide will be given as phi mn xy is equal to kmn cos m pi x by L cos n pi y by W, and that is the format of the or that is the form of the eigenfunctions or the solutions of EG. So EG will be of this form, phi mn form, right? And mn are the mode number. What is mode? That I hope you know. Mode means in case of a rectangular waveguide or a rectangular microstrip antenna, mode indicates how many half wavelength variation occurs along that particular direction. So m means how many half wavelength variation along x direction, and n means how many half wavelength variation along y direction. Now we say that the dominant mode is TM10 or TM01. If we say TM10, that indicates that along the x direction there is one half wavelength variation and along the y direction there is no half wavelength variation. Now let us see the field distribution. If I solve this, then what will the field distribution within the patch? The field distribution you can see is shown here in this figure. Now 0 to L is the length, along the length you see for the dominant mode TM01 mode, what is happening? Only half wavelength variation along the x direction and there is no variation along the y direction. So voltage is maximum at the center, current is maximum at the edge, both the edge. Why voltage is maximum at the center and voltage is minimum at the both the edge? Because at both the edge you have we have got current is maximum at both the edge, voltage is current is minimum at both the edge, voltage is maximum at both the edge. These red lines they show the current, and black lines they show the voltage. Now see, when you have got an open circuit, there is no current, and when you have got an open circuit, there is the maximum voltage. So voltage will be maximum at both the edges, because edges are open circuit or magnetic boundary wall. So in the edge you will have maximum voltage and minimum current. At the center there will be minimum voltage and maximum current, because there is half wavelength variation, one mode. So since there is a half wavelength variation, at both the edges you have a maximum voltage, therefore minimum voltage will be exactly at the center. Similarly, you have minimum current at both the edges, therefore maximum current will be exactly at the center. So this is for TM01 mode. We have seen one half wavelength variation. Then TM02 mode, you can see there are two half wavelength variations. The 03 mode, there are three half wavelength variations. So this is what happens, or how the field is distributed within the patch or in the microstrip antenna below the patch. So we are seeing the current maxima and current minima. Now let us do a simple analysis. For the simple analysis, we will go back to Maxwell's equation. We now know from the similarity of the patch antenna with the waveguide that there is easy field. So we will solve for easy field, then we can find out the other fields. So since there will be easy field, starting with Maxwell's equation and start with Maxwell's Correl equation, proceed as you have proceeded in case of a waveguide, you will get del square Eg plus k square Eg is equal to 0. Then use separation of variables. Using separation variables, you will get Eg is equal to cos m pi x upon L cos n pi y upon W. Right? So this gives you the TM-MN mode. This gives you us the TM-MN mode. Now use this value, use this Eg value in the first equation, del square Eg plus k square Eg. There put this cos value of Ez. Now if I put this value, then you will get minus m pi by L square plus minus n pi by W square plus k square into Ez is equal to 0, as in case of waveguide. So you will get this value. Now that into Ez. Ez is not equal to 0. Since Ez is not equal to 0, if Ez is equal to 0, field is 0, everything is 0. So it is not an antenna. So Ez cannot be 0. So what will be 0? M pi by L square plus n pi by W square minus k square will be 0. From that you can get that from that you will get k square is equal to m pi square by L plus m pi by W square. Now k is the wave number. Use the expression for k. Wave number is k is equal to omega root over mu 0 epsilon 0 root over epsilon r. So that from that you know what is omega. Omega is equal to 2 pi f. Use all these values. For k, put omega root over mu 0 epsilon 0, which is 1 upon c root over epsilon r. Then for omega put 2 pi f. From that you can find out what is f. So f will be c upon 2 pi root over of epsilon r into root over of m pi by L square plus n pi by W square, and c is equal to 1 upon root over of mu 0 epsilon 0. So that gives us the resonant frequency of the microstrip antenna. This is a simple expression for resonant frequency. Now in the 1-0 mode, put m is equal to 1, n is equal to 0. So if I put m is equal to 1, n is equal to 0, then second part is within the root over is 0. first part is pi by L square root square root. So that is pi by L. So pi will cancel out. F will be C by 2L root epsilon R. Okay. Now let us see what are the advantages and disadvantages of the microstrip antenna. With this basic knowledge, we will see advantages, disadvantages of microstrip antenna. Then we will take a break of 5 minutes. So advantages are, there are various advantages. Some important advantages I will show you. One is low profile, which means its size is small. So in all directions, its size is small compared to any other antenna. So it maintains a low profile. Therefore, since it is have low profile and the substrates are usually flexible, therefore this can be conformal, which means it can conform to any surface. So on any surface we can put this antenna. Then easy to fabricate, because PCB fabrication has become so easy that it is easy to fabricate. Simply use the etching or photolithography technique, you can fabricate it. Easy to feed. Feeding the microstrip antenna is the easiest compared to all other antennas. So you don't require a matching network or a proper feed design like other antennas. Simply you can use a coaxial cable, feed the microstrip antenna. So that is the most beautiful thing about the microstrip antenna. Feed is very easy. Then easy to use in an array or incorporate with other microstrip elements in the circuit. So if you have a PCB circuit, then on the PCB circuit you can design a microstrip antenna. So there will be other circuits and there will be the antenna that you can see in your mobile phones. So there are other circuits. Mobile phone PCB has other circuits and the microstrip antennas. So it is easy. So you can have circuits and antennas put together in one PCB. So that is another advantage. Then radiation patterns are somewhat hemispherical and with moderate directivity. About 6 to 8 dB is the directivity of the microstrip antenna. So being a small antenna, it gives you 6 to 8 dB of directivity, typical directivity. That is an advantage. So these are some of the advantages of microstrip antenna. There are various other advantages. Go through the Balanese book, you will see those. Now let us look at what are the disadvantages of microstrip antenna. One disadvantage is it has low bandwidth, typically 2 to 3%, definitely below 5%. In its basic version, the microstrip antenna has below 5% bandwidth. Of course, nowadays there are techniques to enhance the bandwidth, but typically microstrip antenna will have less than 5% bandwidth. Then the efficiency can be lower, because compared to other antenna, efficiency will be lower because the size is small, aperture size is small, the radiating aperture is small, or effective radiating area is small. It will have lower efficiency compared to other antennas. And there will be conductor losses, there will be dielectric losses, because we are using the conductor on the top and bottom, so conductor losses will be there. Dielectric losses will be there in the dielectric. Then if you have thin substrate, this is more, these losses are more. Then there can be surface wave loss. Then there can be surface wave loss. This is severe for thicker substrate. If the substrate is thick, then there will be surface wave loss. What is surface wave loss? Surface wave loss comes from the fact that we are exciting the antenna. So we are exciting an electric field within the substrate. That field will propagate along the substrate. So if it propagates along the substrate and it comes to the end of the substrate, it will propagate like a radiated field. So those fields which radiate through the surface, along the surface of the substrate, are called surface wave. So loss due to that is undesired. It is not desired loss. Loss due to the antenna, radiation due to the antenna is desired, but radiation due to the substrate, that is not desired. So that is a thing which comes in the microstrip antenna. Typically, it is a typical feature of microstrip antenna. Although it is a drawback, it is a typical feature of microstrip antenna. Half wave dipole antenna, you don't get these features. So this is a basic background on the microstrip antenna. And now after this, we'll see the feeding of the microstrip antenna. So let us take a break for 5 minutes. Detail. So in this time, if you have any doubts about microstrip antenna or what we discussed, if you have any doubts, please ask me questions. I will answer you those questions. Or try to revise what we discussed. Try to remember or revise that.